Hello and welcome back to MongoDB's YouTube channel. My name is Asavri, and in this video, we will be understanding the concepts of Atlas search and we will be utilizing the search indexes that have been created in the part 1 of the video. To do a recap of the first part of the video, we learned about the basic concepts of Atlas search and also created indexes using different mechanisms. The mechanisms that we covered in the first part of the video were using the Atlas CLI, the Atlas UI, and the Spring Boot application. In this video, we will be utilizing all the indexes that have been created in the first part to perform the search using the Spring Boot applications. So let's begin and start and understand how do we perform search on these indexes. So as I said, in this part of the video we will be understanding on how to utilize the search indexes. If you have followed the part 1 of the video, you would have seen this application already, where we have tried to create 4 different indexes using the Spring Boot application. This repository contains more code which utilizes these indexes using the REST API calls. The entire video would be divided and we will be talking about 6 different cases to utilize these 4 indexes. So let's understand each of these index in detail. After following the first part of the video, you would have the indexes created in your Atlas cluster in the Atlas search section. So you would see this test index from 01 to 04 already been created in the UI. So let's understand each of them one by one. To utilize the first index, let's see what this index talks about. So go to edit with JSON editor, and if you see, this index contains where the dynamic mapping is set to true. What this means that some of the fields of the text fields will be dynamically and automatically indexed. You do not need to create a separate mapping for few of the fields in the documents. So when you set the dynamic mapping to true, some of the text fields would automatically be indexed. A very good example is what we are going to see in the Spring Boot application. So let's go and see the search service and see what the code talks about. So, if you see the first part of the code, where we are basically performing a simple search operation, and we would be using a keyword inside this function, which is going to search the keyword in the title, plot, and the full plot field. So this entire query is written in three different stages: the dollar search stage, then we have project, and then we have limit. To run this, let's see with an example. So if we go back to this controller and run this, and if you want to see any of the movies that have the word cartoon in their plot, title, or full plot, should be seen as a result of this REST API call. So if you see, we have searched with the word cartoon, and the word cartoon also occurs in plot, also occurs in full plot. Similarly, it occurs in full plot for some. So if you see the index that you have created, we have not specifically mapped the full plot or the title or the plot field, but these fields have automatically been indexed. Now let's see the second part or the second search index that we have created. Let's go back to the Atlas UI and see what the second index talks about. The second index, we have created index on the genres field and on the year field. We would be utilizing these index with 2 different cases. The first case is where we need to find all the movies of a specific genre, and then this index would be utilized. In the second part, or in the second case where we are utilizing this index, is basically where we create buckets on the year and on the genres. So what the second part of the query does is it will count the number of movies in each specific genre, and it will count the number of movies in every 10 years that have been released. So let's see the first part, where we want to see all the movies of a specific genre. Let's go back to the code. In the search service, we see the second function, which is search movies with a specific genre. Again, we have utilized three different stages, which is dollar search, dollar project, and dollar limit. The dollar search is basically going to search directly with the keyword that we give on the genres field. This is a very simple example of creating mapping. Now, if we want to run this, let's go back and see how this works. Now we want to see all the movies with the action genre. And if you see the results here, you see all the movies, five movies we see with the title where the action is genre. Now the second case that we discussed was how do we create these buckets. Let's go back to search service and see how do we categorize. Now, this entire REST API, what this does is it first categorizes the movie based on the genre field and then counts every movie that have been released in the specific genre. Similarly, it performs the same on the year field and it creates the boundaries. So if you see the line number 78, it creates boundaries with every 10 years. So let's run this and understand how this is going to work and how the results we will see. So if you see, the total number of movies is 125, and we have created buckets here where we have categorized all the movies, where we have utilized the second index that we have talked about. So you see, we have in total 71 comedy movies, 42 animation movies, 29 family movies, and so on. And when we also created index on the year field, so it has created buckets on every 10 years. So from 1990 to 1999, 19 movies have been released. Similarly, from 2000 year 2000 to year 2009, 62 movies have been released. So this is how the index 2 or the mapping, it can be utilized. Now let's understand the third index that we created. The third index that we created was specifically for the autocomplete feature. As we have already discussed in the first part of the video, the autocomplete feature allows you to search with only a part of the complete sentence or the keyword, and it should be able to give you the results. The very good example of having an autocomplete feature is the Google search. If you go on Google and type how to perform, it will give you plenty of operations or plenty of options as a response. You can select one of them and then it performs the search. Similarly, we are going to do something of the same sort in our case. So let's understand what the search function does. Now, in the search function, if you see the full plot field, it contains a long text. So if you do not want to write the complete text, you can just put in the query only some part of the text and then perform the search. So here we are utilizing again the three stages: the dollar search stage, which is using the autocomplete feature on the keyword that we are going to pass in the REST API call. We have the dollar project field. Now inside the project field, you also see line number 96, which talks about highlights. So this highlight will specifically highlight the fields that has performed the search. We'll see how this works, and then we have a limit. So let's run this REST API call and see how that works. Now, if you see in the query part, I have just given cow and spow, which can be a short form for, say, cowboy or Spain. So if you see any of the words which has Spain in it or a cowboy word in it, should also be returned as the result of this REST API call. For example, if I show you, let's understand this. Now you have a complete full text, full plot field, where this is a long text, as you can see. Now in this entire full text, full plot field is divided into different parts. Whenever it finds a hit, it gives a score value to it. For example, it searches from here to here. Now, till here, it found a hit at SPAIN, which where in the query we just gave SPA. So you see, Spain, no, and he, and it says the word hit. That means it has found the match. And then it moves ahead with the further part of the full plot text. For example, it has found again where it mentions about Spain. Similarly, it also mentions about cowboy somewhere in the later part of the text. It also performs a hit in that case. So this is how your highlight part of the project works. And this is what the autocomplete feature is all about. Now, with this autocomplete feature, which we can also perform fuzzy searches. Now, what fuzzy searches are is, even if you misspell a word in your search bar in Google or say any e-commerce application, it would still show you the relevant results. This is what fuzzy search is. Now, to perform this fuzzy search, let's see how your search query could be written. This is the function for your misspelled title. Now, in this, we are utilizing the text index 3, which we have already talked about, and it performs the search on the title field where we would be misspelling a keyword of the entire title, but we would still get the results. And then it would use again the project and the dollar limit operation. To run this, let's go back and run the REST API call, where if you see inside my query, I gave the keyword as dinosaur, and if you notice carefully, the I have misspelled the word dinosaur, but I would still get the results. For example, if I show you, I misspelled the word dinosaur, but the title of the movie with the correct spelling is also displayed as a part of the result. This is what fuzzy search is all about. Now, let's understand the last index that we have created. Now, in the last index, it talks about synonyms. Now, what are synonyms and how that works? This entire index is divided again into two parts. The first part of the index uses the Lucene.English, which is nothing but a language analyzer which is provided. There are different analyzers which are provided. For example, we have for Spain, we have for Spanish, we have for Chinese, and there are other languages support which is also provided. This is the inbuilt analyzer which is provided by the Atlas search. Now, in the later part of the index, if you see, we have also mentioned a portion where we talk about synonym. Now, inside the synonyms field, we have mentioned three different fields. The first field is the analyzer, that is how it is going to analyze, where we are using the English analyzer. Then we give the name of the synonym, and in the third part, if you see, we have a source. Now, what this does is, this is where we create the mapping for each of the words where we want to perform the synonym search. Let's understand with a very simple example. Now, if you want to book a movie, and if you want to book tickets for a movie which talks about, say, love, romance, affection, and other things. Now, what we do is, even if you type affection or passion sort of keywords, if you have created those mapping inside the collection, then those will also be returned as a part of the query where you're only searching with the word, say, love. Similarly, if you the words like car, automobiles, bikes are all related to each other, or maybe somewhat synonyms to each other. Again, we create a mapping for this inside the collection called test synonyms. You can name the collection name anything that you want to like. In this case, we have used the test synonyms name. Now, we have created this mapping inside the collection. Let's go back to collection and see how this mapping looks like. Let's see the mflix field, and then you see a test synonym collection. Now, inside the test synonym collection, you see we have two different mappings which have been created. One is if you input as love or romance, where the synonyms have been created as love and romance. You can type that mapping type as an explicit, or The other mapping type is equivalent, where we have put the synonym as car, vehicle, and automobile all together. Now, if you search for the word vehicle, a movie with the name car, or the full plot with the name car, should also be displayed as a part of the result. Now, let's see how you can perform the search operation through the search service class. Now, inside this, if you see the last option, last method that we have, the search with synonym field, we would be giving a specific keyword for which from which we want to create perform the search operation, and it will perform on the full plot field. And the last part is where we give the name of the synonym. So this synonym name is nothing what we mentioned in the index when we created, and then it has limit and the project operation. Let's see how this works. So if you see line number 39, I'm performing the search, and if I say I want to search all the movies which talks about maybe or romance, for example. And now if you see the results, the movie is not only with the word romance, but also words like love has also been seen as a part of the result. So this is what your synonym mapping is. If you do not want to perform the synonym mapping, then vector search is the answer to you. But if you want to perform atlas search and do not want to create these vectors, then you can also perform this synonym mapping you by creating a different mapping inside the collection that you mention in the search index field. So we have seen 6 different cases on how you can utilize the 4 indexes that we have created in with the Spring Boot application. At the end of this entire application, you're also supposed to delete all of these indexes created. Either you can delete again these indexes through your Atlas UI, or through CLI, or through the Spring Boot application. To delete this application in the Spring Boot, we have created another function to get all the indexes that have been created and then perform the delete operation. Now let's see how you can perform this delete. So this is what we are doing, and we name the DB name as sample mflix and the collection name as movies, and perform the delete. Now if you go back and see, your search indexes would be deleting one by one. So you see all the deletion are in progress. So make sure after you have completed your application and after you have performed all the search, to delete all of these indexes. Since I have created 4 different indexes using the Spring Boot application, I am using an M10 cluster. If you do not want to perform 4 different indexes altogether, you can use the free tier Atlas cluster, which allows to create 3 indexes on one time, and these indexes could only be created through Atlas UI. So this is the end of the video, and I hope you have understood about the search capability that the Atlas search provides. There is also a part 3 of the video where we would be talking about some custom analyzers and some advanced search that could be performed using the Atlas search feature. So stay tuned for the third part of the video. Till then, if you have any questions, don't forget to comment down and like the video. Thank you.